In this second lesson on chapter 6, we're still going to focus on these three new trig functions, so sec, cosec, and cot. Okay, and just to remember as well, sec theta, this was 1 over cos theta. Cosec theta is 1 over sine theta. And then the last one, cot theta, was 1 over tan theta. And that was all that these meant, really. You might remember that we could look at the third letter. So C, to remember that it's 1 over cos, S, to remember it's 1 over sine, and T, to remember it's 1 over tan. Now we're going to derive some new identities involving these functions. So the two identities we know already, sine squared theta plus cos squared theta equals 1, and sine theta over cos theta equals tan theta. So we're going to derive some new identities. And we're going to do that using one that we already know already. So sine squared x plus cos squared x equals 1. What I'm going to do to this statement is I'm going to either divide it by sine squared, or I'm going to divide it all by cos squared x. And this is going to give me two new identities. Okay. So if I divide this whole statement by sine squared, I would get sine squared over sine squared, which is 1, plus cos squared over sine squared. Well, if sine over cos is tan, then that must mean that cos over sine is 1 over tan, which we now know is cot x. So this is going to become 1 plus cos squared over sine squared. That's going to be cot squared x equals 1 over sine squared, which we know is cosec squared x. And this is a new identity that we can use. If we do the same thing, but we divide it all by cos squared, then I'd have sine squared divided by cos squared, which would be tan squared, plus cos squared divided by cos squared, which is just 1. 1 divided by cos squared, which is sec squared x. Okay, so we've got this pair of new identities that we can use. Now, you could remember them, or you could just remember how to get them, and then you could derive them quickly when you think you might need them in a relevant question. Obviously, it's a bit quicker if you can remember them, but there's lots to remember, so sometimes just remembering how to derive them, like I just shown you, is a bit easier. They're fairly easy to remember, especially if you write them like this instead. So with the 1 at the front, you can see that they kind of match. So if I write them like this, so you can see that they're both just 1 plus tan squared, except this one is 1 plus 1 over tan squared, equals sec squared. So here we've got like the regular versions of tan and sec, and here we've got the co-versions of tan and sec. So we've got cotangent and cosec. So they kind of match in that way. If you can remember this one, then I feel like you can remember the second one, because you just swap tan for cotangent and swap sec for cosec. Okay. So there's lots of context where you can use these identities to help you. And it's very similar to the questions we've done before. It will either be solving some sort of equation using identities, or it will be doing some sort of trig proof, so using one result to prove another. So I'm just going to look at this example here for solving an equation. So we've got 4 cosec squared theta minus 9 equals cot theta between 0 and 360. So let's just write down those two identities. So 1 plus tan squared theta equals sec squared theta. And we've got 1 plus cot squared theta equals cosec squared theta. Okay. Now in this question we've just got two different functions. We've got cosec squared and we've got cot. So we've got something to do with sine and we've got something to do with tan. So we could do with swapping it so it's only in terms of one function. So what I'm going to do is I'm going to swap out the cosec squared using this identity here. So cosec squared theta I can swap for 1 plus cot squared. So this is 4 times 1 plus cot squared theta minus 9 equals cot theta. And now it's just in terms of cot and cot squared. So we've just got one function in there, which is a bit nicer to do it with. And we're just going to rearrange it into a quadratic. So I get to there. And now this is obviously just in the form of a quadratic. You could think of it as 4x squared minus x minus 5. I'm just going to solve that on my calculator. So my first solution, and this would be for cot theta, is 5 over 4. And my second solution for cot theta is minus 1. Now I've just got to solve both of those in our interval 0 to 360. Now, we obviously don't have an inverse cot button, so we need to change this to talking about tan, which is 1 over that, so tan theta would be 4/5, or tan theta would be 1 over minus 1. Actually, that is still minus 1. So now let's find our solutions. Inverse tan of 4/5. So my first solution here is going to be 38.7. You can find the rest of the solutions by adding 180, because the period of tan is 180, so that's 218.7. I don't think it's going to be any more after that. No, get 398 to be the next one, so that's too big. This one over here, if I do inverse tan of minus 1, now I get minus 45. That's obviously not in my range though. I'm just going to cross it out. To get to the next one, just add on 180. So that'd be 135, add on 180, 315. Okay. So my answers, I'm just going to write them in order: 38.7, 135, 218.7, and 315. Those would be my solutions there. Okay. Now, all of the solving questions are basically some arrangement of that. So using one of these two identities to write your equation in terms of just one function. Here's another example of solving using some of these new identities. And pick this one just because it's got a bit more going on. So I've got sec theta minus cos theta all squared equals tan theta minus sine squared between 0 and pi. So we're in radians this time as well. So when we come to solving, we need to make sure our calculator is in radians. Okay. Right, if we expand this, that'd be sec squared theta minus 2 sec theta cos theta plus cos squared theta. And I'm just going to keep the right hand side the same. Okay. Now, there's a few things that we can try and notice here that might help us, because at the moment we've got lots of different trig functions, so it's quite untidy to deal with at the moment. Things that I've noticed, I've got a cos squared here and a minus sine squared here. So if I move this across, I could have cos squared plus sine squared, which would give me 1. So that's quite convenient, so I might do that in a minute. This term here is also interesting. Sec theta times cos theta. Well, sec theta is 1 over cos theta. So we've got 2 times 1 over cos theta times cos theta. Well, that's just going to give me 2, because I've got cos theta divided by cos theta, which is 1. So let's put some of these things in. So this here is just going to become minus 2 plus cos squared theta. And I'm also going to move this sine squared to the left-hand side by adding it to both sides. So now I've got sec squared theta minus 2 plus 1 is what this thing here becomes. So now I'm left with sec squared theta minus 1 in total equals tan theta. That's a little bit better, isn't it? Sec and tan here that are involved, I think this reminds me of one of our identities. Our two identities, our new ones, were 1 plus tan squared would give me sec squared, and 1 plus cot squared would give me cosec squared. Now looking at those two, I think this top one's going to be the most important one here. 1 plus tan squared is sec squared. Well, that would mean that I could write that as sec squared minus 1. So tan squared theta, I could write as sec squared theta minus 1, which is actually exactly what we've got here, isn't it? So this is then tan squared theta equals tan theta. Now we've just got one function. So I'm going to move them all onto the left-hand side and then factorize it. And it's important that you do that rather than dividing by tan, because if you do that, you would lose some of your solutions. So you need to try and move them onto one side and factorize, really. So I can factor out a tan like this. And now I've got either tan theta equals 0 or tan theta equals 1. Now I've just got to solve it between 0 and pi. So let's just go through and find those solutions. So again, make sure your calculator is in radians. So inverse tan of 0, well, your first solution is going to be 0. And then we can add on 180. So we're going to go 180 and then, actually it won't be 180, will it? Add on pi instead, really, because we're working in radians. So it'd be 0 and pi. This other one, inverse tan of 1, that is pi over 4. And then my next solution, I would add on 180 or add on pi. But if I did that, that would then be outside my limits. Okay, so here my solutions are just 0, pi over 4, and pi. Okay, so later on in the exercise, there's lots of questions like this, but they all come down to just using your identities to try and get it in terms of one trig function rather than several. And I'd suggest that if you get stuck on those, then definitely use the work solutions to help you. Okay, let's have a look at a couple of proof examples. So in this style of proof question, what we've got to do is we've got to start with the left-hand side or the right-hand side and rearrange it to make it look like what is on the other side. Okay, so we don't treat it like an equation. We have to take one side, rearrange it to make it look like the other one. So for part A, I'm going to start with the left-hand side. Okay, I'm going to start with cosec squared. Sorry, not even squared, is it? It's to the power of 4 theta minus cot to the power of 4 theta. Now, hopefully, you can spot that this is a difference of two squares. Okay, they're not squares, they're to the power of 4, but obviously to the power of 4 is something squared. So a bit like if I have x squared minus 9, that becomes x plus 3, x minus 3. Likewise, if I had a squared minus b squared, that becomes a plus b, a minus b. If I make it to the power of 4, then that's going to become a squared plus b squared, a squared minus b squared. Okay, so we can use that same pattern to help us here. I'm going to rewrite this as cosec squared theta plus cot squared theta times cosec squared theta minus cot squared theta. Okay, using difference of two squares is really useful in these questions, especially if you've got a power of 4, because we don't really have any identities that talk about powers of 4. So if you use difference of two squares, then we can make it identities or functions with a squared in, which we do have identities that talk about. Now, let's just write down the two new identities that we had. So we had 1 plus tan squared gives us sec squared, and we had 1 plus cot squared gives us cosec squared. Okay. Now, this bracket here on the right seems quite similar to this one here. Cosec squared minus cot squared, well, if I look at this equation here, cosec squared minus cot squared, that's just going to give me 1. So this bracket here actually becomes 1. So we're just left with cosec squared theta plus cot squared theta, then times 1. So we're just left with this bracket, really. Now, can we try and make that look like this? So I suppose the thing to spot here is that what I'm aiming for has only got cos theta in it. So I need to try and change these functions to talk about cos theta instead, if I can. Well, cosec squared, remember that's 1 over sine squared theta. So we can easily change that to a cos squared in a minute. Plus cot squared, that's 1 over tan squared. So I could write that as cos squared theta over sine squared theta. Okay, that's our identity from before, but flipped upside down. Now I could add these together. They've got the same denominator. And that gives me the top of the fraction that I was after, 1 plus cos squared. And then I can just change the bottom using the identity that we already know. So sine squared is equivalent to 1 minus cos squared. And then we have proved our results. For this second example, we've got sec squared theta minus cos squared theta equals sine squared times 1 plus sec squared. Now remember in these, you can either start at the left or the right, it doesn't matter. I think in this one I'm going to start with the right. My reasoning for that is because I would much rather expand something than try and factorize something generally. It's probably going to be a bit easier. But it doesn't really matter. You should always be able to do it both ways because obviously it's a proof and they're both true. But sometimes you might start at the left and you play around a bit and you get stuck, and then you can try and do it the other way, and that might be easier or more obvious. Okay, so sometimes it's worth trying both if you're getting stuck. So let's start at the right hand side here. So I've got sine squared theta times 1 plus sec squared theta. I'm going to multiply this out. So I've got sine squared theta plus sine squared theta sec squared theta. Okay. Now I'm aiming for this here. Okay. So I'm aiming for something which has just got sec squared, so that's 1 over cos squared, and cos squared in it. So I guess I could change this later on. That might be useful to do. I'm going to leave it for now. But this term here, sine squared times sec squared. So that's sine squared times 1 over cos squared. So that's sine squared over cos squared, which is tan squared. Okay. Now I obviously don't have a tan in my answer, but using some of my new identities, I can turn this tan into something that does talk about sec or cos. So this top one, if I rearrange this, that would tell me that tan squared is sec squared minus 1. Okay, so I've replaced my tan squared with a sec squared theta minus 1. And now I'm going to swap this sine squared out for a 1 minus cos squared. And then if I simplify this, I'll just be left with sec squared theta minus cos squared theta. Okay, there we go. Okay, there's one more type of question that we're going to look at. I'm going to do one of these questions. This is like a year 1 question, just to remind you how this sort of format of question works. So I'm just going to do part A, I think. So given that cos theta equals minus 3/5, and that theta is reflex. Now remember, reflex means that theta is less than 360, but it is bigger than 180. Okay, and we've got to find sine theta. So we can use our identity. We can use sine squared theta plus cos squared theta equals 1. So that is then sine squared theta equals minus 3/5, sorry, not equals, plus minus 3/5 squared equals 1. We can rearrange that. So I'm going to do 1 minus 9 over 25, because that's what 3 over 5 squared is. So that gives me 16 over 25. Now when I square root this, sine theta is either plus or minus 4 over 5. Now that's a problem because we need to decide which one is it. So let's draw the graph. So sine theta looks like this. And we know that it is a reflex angle, so between 180 and 360. So that's that bit here. Now we can see that sine theta between 180 and 360 is always negative. So for that reason, we can say that sine theta must be minus 4/5. Okay. Sometimes you might have to do a bit more than that. You might have to also think about the original function. So you might have to think about cos theta. And cos theta looks like this. Now here, this is where 180 is. So cos theta is reflex between here and here. So cos theta is a bit more complicated because sometimes it's negative and sometimes it's positive when it's reflex. But we were told that it's negative. So we know that our answer must be in this bit here. Just in that bit there. So you can be a little bit more precise about where the angle is. So actually it's in this bit here somewhere. Okay. So you might have to sort of think about both. Now what we're going to do is look at the same sort of question, but using some of our new identities. So here we're told that tan A is negative 5/12 and A is obtuse. Okay. So obtuse, this means that the angle is between, that's right, A, so it's bigger than 90, but it's less than 180. Okay, if it's less than 90, it would be acute. And then if it's between 90 and 180, it's obtuse. And if it's bigger than 180, then it's reflex. Find out the values of sec A and sine A. So I'm trying to find something to link tan A and sec A. So one of my new identities was 1 plus tan squared, and I'll do it in terms of A, equals sec squared A. The other one was 1 plus cot squared A equals cosec squared A. So I'm going to use this top identity to help me. So 1 plus tan squared A equals sec squared A. So 1 plus minus 5/12 squared equals sec squared A. So minus 5/12 squared is 25 over 144 plus 1 gives me 169 over 144, and then I need to square root that. So this tells me that sec A is going to become plus or minus 13 over 12. Okay, we don't know which one it is. We've got to decide which one it is now. Now in the original question, we were told that tan A was negative and that the angle was obtuse. So let's just draw a quick sketch of tan. We were told that it's obtuse. So remember that is between 90 and 180. So that's going to be just that portion there. Because this is 90 and this is 180. So it's just going to be down there. So you can see that tan is negative, which makes sense given the information here. So sec A is this. We could think about the graph of sec A, but it's probably more convenient to think about the graph of cos A, which is 1 over this. So that would be plus or minus 12 over 13. Let's draw the graph of cos. This. So this is 180, and this point is 90. And we are between those two, we're between 90 and 180, so we're just in that portion there. And we can see quite clearly from the graph that cos is negative. Therefore, sec will also be negative, because that doesn't affect the sign, just doing 1 over it. So sec A is going to be negative 13 over 12. Okay, and that's the first part done. For part B, to find sine A, there's a couple of different ways you can do it. I'm going to do it by the same sort of method that we've just done, just so I can show you the method again. So we want something that links tan and sine. So actually I'm going to go for this one here. 1 plus cot squared A equals cosec squared A. Now that might not be immediately obvious why I picked that one, because it doesn't look on the face of it like it talks about tan or about sine. But cot is 1 over tan, so really I do have that one. And cosec, that's 1 over sine, so I do really have that one as well. So I've got 1 plus cot squared, that's going to be 1 over this thing squared, so that's minus 12 over 5 squared equals cosec squared A. Now I'm just going to work out this left-hand side. So it's 12 over 5 squared plus 1, and I'm going to square root it. So it gives me 13 over 5 plus or minus is cosec A. Now I don't really want cosec A, I just want sine A. So do 1 over both sides. So sine A is going to be plus or minus 5 over 13. And I just have to decide which it is. So let's draw the graph of sine. There's 180. There's 90. It's obtuse, this angle, so we want to go in between those two. So it is in this region here. And we can see that it must be positive. So sine A must be positive 5 over 13. Now, a slightly quicker way we could have done part B is we could have actually used our answer from before to help us. because we know what sec was, we know what cos is, and so on. I could just use sine A over cos A is tan A, and then sine A over cos A, well, sec A is minus 13 over 12, so cos A is going to be minus 12 over 13, equals tan A, and we were told that in the question that was minus 5/12. And then from that, you can calculate minus 5/12 times 12 over 13, sorry, times negative 12 over 13 gives you positive 5 over 13. So you could get to it that way as well. Okay. Okay, so for some questions to do, I've picked out the questions that are relevant to the examples that I've done and are probably the most common questions you might come across in an exam. So question 1 is just simplifying some expressions using our new identities. And then questions 3, 5, 6, and 8, you've got some about this sort of style of question, about being obtuse and reflex. You've got some equations to solve, and you've got some proofs to prove. Okay, so you can have a go at those questions now.